Hello students, in today's class we are going to see the projection of planes. Previously we have seen the projection of points and projection of lines. Now we are going to see the projection of planes. A plane is a two-dimensional surface which is having length and breadth. Okay, so in a projection of plane problem, what is usually asked? Okay, so usually you are asked to draw the front view or top view of a planar surface which is inclined or maybe parallel to the any one of the reference planes, right? So this is what you will be asked, and then what will be given in the problem, right? So in your problem you will have the description of the planar surface, right? So they'll give the length of the planar surface and then its position with the HP and VP. That means the inclination details will be given. Okay, in which manner we can solve this problem? Okay, so first in your problem two details will be given. Okay, first one, as I said, the planar figures dimension and then the inclination. Okay, so in inclination, first inclination will be the surface inclination, the surface inclination with the reference plane such as HP and VP. Okay, and then the side inclination or edge inclination with the reference plane. Okay, these two details will be given. Okay, first the surface inclination and then the side inclination, right? Okay, so you can see this is the types of problems usually uh, available in the projection of planes. So first one, surface parallel to HP. You can see this is a rectangular plane which is parallel to HP and perpendicular to VP. So in your front view what you can see, you will see a line. Since it is perpendicular to VP, you can see a line in the front view. This is the front view, and in top view you can see the whole rectangular surface, right? This is the front view and top view. Okay, so in your front view you can see the line and in your top view you can see a rectangle. Okay, first we need to draw the rectangle and then we will obtain the line which is in the front view. And then the next case, surface parallel to HP. Sorry, this surface is parallel to VP. It is even wrong. It is surface parallel to VP. Right? So what will be your front view? Your front view will be a rectangle, right? And then the top view will be a line which you can see in the PPT. So this is the front view and top view. So in your front view you will get the rectangle as per the given dimension, and then the top view will be a line. So you need to project the edge corners of or edges of the rectangle, right? A dash and C dash will be projected downwards so that I'll get the top view. So this is the second case, the surface parallel to VP. And then now the inclined case, the surface inclined to HP and perpendicular to VP. Okay, so this is the rectangular surface again. Okay, this surface is inclined to HP. We can see a line which is parallel to HP, that is the line. Okay, and then in front view, since it is perpendicular to VP, in front view you can see a line. This is the line. Okay, and the inclination, since it is inclined to HP, the inclination can be seen in the front view. Okay, and then the top view. In top view you will not see the complete rectangle, you will get a shrinked somewhat smaller rectangle than the original one. This is the top view. So this is the front view and top view. We cannot obtain this shrinked surface in direct steps. Okay, like this you cannot obtain. First what you have to do, you have to consider, since it is inclined to HP, you have to consider this rectangle as parallel to HP. If a surface inclination is given, surface inclination, right? Surface is inclined to HP means what you have to do is you have to consider this surface as parallel to HP, as parallel to HP. Okay, so first step, you will get a rectangle like this, and then this is the front view. Okay, this is the front view. This is the line, true length of the line. This is the first step, this is second step, right? And then now the inclination is known. Inclination is maybe 30 degree. Okay, now this line will be tilted 30 degree. Okay, this is the third step. After tilting this, you need to project these two edges. Also you need to project horizontally. By projecting these lines, you will get the original shape or top view of the, this is the top view of the inclined rectangular surface. Okay, so far we have seen the surface inclination, right? Now we are going to see the surface and side inclination. In the first slide I have told you that first the surface inclination will be given and then the side inclination will be given. Okay, so this is what we have solved in the previous slide. Okay, the surface is inclined to HP. Okay, so now the side is also, this side will be, this one side will be inclined. You can see this. Now it is tilted. Okay, the surface inclination, this is the surface inclination and this is the side inclination. Okay, in front view also you will have a shrinked surface, in top view also you will have the shrinked surface. You need to draw this final front view and final top view. So the final front view and top view will be like this. Okay, you cannot obtain this final front view and top view in direct step like this. We need to follow the uh, 3 to 4 steps in order to obtain these final shapes. Okay, we will see one problem, okay, from which you can understand the concept of projection of planes. Okay, so here a rectangle of 30 mm and 50 mm side is resting on HP. Okay, one of the side, one of the side is 30 degree inclined to VP and surface is inclined 45 degree to HP. This is what given. Draw its projection. Okay, so first surface inclination is first step. Okay, surface inclined to which plane it is inclined to HP. So what you have to do is we have to assume it as parallel to HP. Okay, so if it is inclined to HP means you need to assume the plane is parallel to HP. This is the first step. Okay, so if a rectangle is parallel to HP means you will obtain the rectangle in the top view. Okay, this is the first initial position and front view will be a line. This is the front view. Okay, now we are going to solve the second step, that is incline, surface inclination. Okay, the surface inclined to HP. Okay, the surface inclination is given with respect to HP. Okay, so now this is inclined to HP. Okay, inclined to HP can be seen in the front view. Inclined to HP can be seen in the front view and inclined to VP can be seen in the top view. This all you should know. Okay, so now the inclination is 45 degree. What you are going to do is you are going to tilt this line 45 degree. Now you have tilted. Okay, A dash B dash and C dash D dash. Okay, you are going to project these two edges. Also you are going to project the top view also. So from A to D you are going to draw a horizontal line, and B to C you are going to draw a horizontal line. So A and A dash will be intersecting here. D and D dash will be intersecting here. B and B dash will be intersecting here. C and C dash will be intersecting here. Okay, join all these points A1, B1, C1, D1. This is the first step. Okay, now you have tilted the surface and obtained the shrinked surface. Now we are going to tilt the side. Okay, the side is inclined 30 degree to which plane? It is inclined to VP. So if the inclination is given with respect to VP means what you have to do is, where you can see, you will see in the top view. So what you are going to do is you are going to tilt this A1, B1, C1, D1 square or rectangle into 30 degree. Okay, so now the rectangle is tilted 30 degree. Side, this is the side inclination. Okay, A1, B1, C1, D1 is tilted. Now project vertically, and you can also do the projection from the front view also. So this is the horizontal projection. So now mark all the points which is intersecting. Now connect the 4 points. This is the final front view. Okay, now and another problem, a 30-degree set square, okay, of long side 100 mm long is in the BP and 30-degree inclined to HP. Okay, so this 30-degree inclination is the side inclination and 45-degree to VP is the surface inclination. So here the surface inclination is given with respect to VP. The surface is inclined to VP. So if it is inclined to VP means you have to assume it as parallel to VP. So the set square is parallel to VP. Okay, in front view only you will be seeing the triangle. Okay, and then the top view will be a line. Okay, so now the surface is inclined to VP. Okay, the inclination is given as 45 degree. Now what you are going to do is you are going to tilt this top view into 45 degree and project all these points, and horizontally you need to project the 3 corners. By projecting this you will get a shrinked triangle, that is the front view, second front view, and we need to get the final front view, that is the side is inclined 30 degree to HP. So inclined to HP will be seen in the front view, that means the 30 degree inclination will be in the front view. Okay, so now we have tilted this rectangle into 30 degree. Since the longer edges inclined means, so here only you will have the, along the 30 degree only you will have the longer edges. Okay, and then project all these points, you will get the final top view. So this is the final front view and final top view. So another problem based on a rectangular pentagon. So pentagon side is 30 mm and one of its side resting on HP on one of its sides with its surface inclined 45 degree, surface inclination 45 degree and side inclination is 30 degree with VP. So surface inclined to which plane? HP. Then you need to consider the surfaces parallel to HP and start drawing the initial position. So parallel to HP means you'll get a pentagon like this. And then the front view. Okay. This is the initial step. Here you may have a doubt. So can I draw the pentagon like this? So can I draw a pentagon like this where one of the edges is parallel to XY? Okay, you may have a question. Here you can see here one of the side is perpendicular to XY. Okay, so here you can see it is resting on one of its sides, right? This is very important. You can see this is one edge since it is having two corners A dash and B dash. Here you can see this is a edge. This is a corner. This is a edge since it is having two corners. Okay. So in your problem they said it is resting on one of its sides. Sides are edges, both are same. Edge or side. Pentagon's one side. So next step what we will do is we will incline this line so that B dash and A dash is on the XY line or B dash and A dash is on the HP. That's what they have given. It is resting on HP on one of its sides. Okay, you can see. So that A dash and B dash is in the HP. So now this case is also fulfilled. If you drawn like this means while you incline this surface only a corner will be touching on XY plane. Okay, then this problem will be wrong. If you drawn like this problem will be wrong. Whereas if they have said it is the surface is resting on HP on its corner, if they said corner means you can draw like this. Okay, so and then you will project all these points horizontally. You will project all these points. Now you will get the top view. Okay, second top view. Now the final top view. In the final top view one of the side will be inclined 30 degree. So any one of the side. Okay, here A1 B1 will be inclined. So this side will be inclined 30 degree. Okay, so you have to tilt this shrinked pentagon into 30 degree. Okay, and then you will project all the 5 points. You will also project horizontally. So by drawing like this you will get the final front view and top view. So this is one more problem, regular pentagon problem. Okay, a regular pentagon of 30 mm side is resting on HP on one of its sides while its opposite vertex is 30 mm above HP. Okay, it is 30 mm and then it is resting on HP on one of its sides while its opposite vertex is 30 mm above HP. Here the inclination is not directly given. Okay, here the inclination is not directly given. What we will do is we will usually incline this line if the angle is given. This theta will be given. Here the theta is not given. Instead of that, this length will be given as 30 mm. Okay, so you can see we will get the front view and top view. Now we are going to tilt this line. Okay, one point will be on the xy and another point will be the on 30 mm above. So this is the, instead of inclination they just given the length. Okay, now you will get the second top view. Now when one side is inclined 30 degree, as I said previously, so one side will be on the xy plane. Okay, so you need to draw perpendicular. Now a1 b1 will be inclined and then projected. By projecting this you will get all the 5 sides. Now you can see a1 b1 is on the xy plane or it is on the HP. So next a circle is given. Okay, so same procedure. So you can divide the circle into 8 equal parts so that you will get the ellipse in a more uniform manner. Okay, you will have more intersection points to connect. First the surface inclination and then side inclination. Here the side will not be given, instead of that diameter, its diameter will be given. The diameter is inclined. A circle of 50 mm diameter is resting on HP. Okay, one end A of its diameter AC, one end A of its diameter AC, which is 30 degree inclined to HP. Okay, while its top view is 45 degree inclined to VP. Okay, so first we have to incline this diameter. This is the diameter, right? A to C will be the diameter. You are going to tilt this diameter into 30 degree and then you can tilt this 45 degree in the top view. Okay, so we can draw vice versa also. So a similar problem will be given here. Okay, so with this we will wind up this video. Okay, thank you.